Hey everybody, welcome back. So in a statistics class, we spent a whole lot of time talking about different formulas on how to analyze a data set, as though that data set is just kind of divinely provided and it's perfect and unbiased. All it needs is some analysis. And in real life, that's just not the case. Data has to be collected by somebody, and it can often be collected really poorly. So poorly, in fact, that any conclusions you would draw from it could be way wrong. So I'd like to take this video to talk about data collection and specifically about the sampling methods that we use to pull people into a sample. As a reminder, the reason why we would sample is we'd like to know something about the population, like the whole body of people, for example, but we might not have access to that entire larger set. It might be that it's too costly for us to ask absolutely everyone in, let's say, the US population what their income is. That would just, take way too much effort for a private individual to undertake, even a company. And as a matter of fact, the US government can only muster the resources to do such a thing once every decade. So samples are far cheaper. Samples might actually be more accurate. Imagine that you were working at a parts supply store and you were selling nuts and bolts, and you needed to measure each nut and bolt to see if they were within the right range of sizes. Like, that's a horrible job. Imagine that your full-time job was to take each bolt individually and measure it and then record it, and then pick up the next bolt and look at it and measure it and record it. How good do you think your measurements would be after a little while? Like, within 20 minutes, you're bored. Within a day, I mean, you want to end it all. So how are you going to record those numbers? Probably very poorly. You'll probably start making stuff up or just eyeballing it and saying, oh yeah, that looks right. This looks, properly, the appropriate length. And so in your attempt to measure absolutely every single nut and bolt to get the population number, you'd actually invite a whole bunch of recorder error. So maybe a sample can maintain your interest long enough that you would have really precise measurements. So maybe a sample could be more accurate. And then finally, some kind of sampling destroys the sample. So if you were supposed to be a taste tester for chocolate, that's a great job, but you would not be allowed to taste test every single candy bar that comes off the assembly line, because then what are you going to sell? You can't sell a half-eaten candy bar. So sometimes the sampling itself kind of destroys the thing that you're trying to test. So you're going to have some kind of sample. You're restricted to a sample rather than the population. And our task today for this slide deck is to figure out, how can I properly select participants to be in my sample? More broadly, it's not just how do I select someone into a sample, but how do I know that the people that are going to be in my sample actually represent the population? It's almost like a catch-22. We're trying to figure out something about the population, and so we draw a sample that hopefully reflects the population. But we can't verify that because we don't know the truth about the population. Right? If I'm trying to figure out what the US population's average income is, I can't then draw a sample that is guaranteed to give me the same average income number that the population would have. I don't know what the true average population income is. So how do we deal with this? And the idea is we at least need a procedure that's not biased. Some kind of selection procedure where we pull people into a sample where we're not going to oversample weird people. right? So if I want average income, I'm not going to have some selection criteria that oversamples or draws people in from the yacht club or the billionaires club or the ski resort or the country club. My sample, it might even be a very large sample, but it would be a very skewed and biased sample. So what we need then is a sampling procedure that doesn't oversample particular groups of people, but kind of gives everybody an equal probability of being selected into the sample. And that'll give us a really good take on what the population parameters are. You see, it's really common for students to think that all you need for really good inference is a really large sample. As a matter of fact, I hear this a lot where people say, wait, you had a sample of 1,000 people? How are you supposed to tell me something about the US population when you only sampled 1,000 people? That seems like nonsense. What you really need is a very large sample. It makes sense, but that's wrong. And here's, I think, a famous historical example that can illustrate how just focusing on sample size can lead you astray. So this famous example deals with the 1936 presidential election between Franklin Delano Roosevelt, FDR, and Alf Landon. Right. So it was a heated presidential debate, and everyone wanted to know who was going to win, who was going to win. And this publication called the Literary Digest wanted to kind of answer that question, take a guess at who would win the presidential election. They had actually correctly predicted the previous presidential election, so everyone was curious, what was Literary Digest going to predict? And so right before the election, they mailed out 10 million questionnaires, 10 million surveys. That's a huge sample size. And they tried to mail it to as many people as possible. If they could find your mailing address, they were going to try to send you a questionnaire. So what they do, they went to the phone books. I don't know if you guys remember phone books, but back in the day before cell phones, if you had a phone, it was attached to a house, and they listed your house phone number in this giant book. It also had your mailing address. So they took every single mailing address from those phone books in the US. They had their own internal list of magazine subscribers, because the Literary Digest was a magazine. And they tried to pull any membership information from clubs like the Rotary Club or things like that, and just trying to send out as many possible questionnaires. They were focusing on a very large sample size. Now, about 25% of people who received one of those questionnaires responded. Now, 25%, I'm not sure, that could be a little low. Then again, they got 2.4 million people to respond. That in and of itself is a huge number. And so people were like, wow, what does Literary Digest say is going to happen? They predicted that Alf Landon was going to win in a landslide. Now they come out publicly with this proclamation, with this prediction, and at least one person was very skeptical. This guy right here. His name was George Gallup. And you might have heard of the Gallup poll. This was an organization that he founded. He was a statistician. And he used a completely different method of sampling, of selecting people into his little group of, turns out, 50,000 voters. Now just think about this. 2.4 million versus 50,000. 2,400,000 versus 50,000. Gallup's sample size was like laughable. And Gallup turns around and said, well, you know what? Yeah, I've only got a small sample size, but I've got a really cool method of selecting people into my survey. And I think Literary Digest is wrong. FDR is going to win this in a landslide. Now, what is George Gallup's quota sampling method that he used? He kind of had an idea of what proportion of people were in different categories. And he went out trying to select people that fit those categories. So if most people live on the East Coast, then he was going to go out and get himself some East Coasters. And if only 10% of the people lived in the Midwest, he was going to go out and only get 10% Midwesters. Actually, it was a little bit more than just geographical. It was based on gender, it was based on age, race, and income. But he set out to get a representative sample of people along these demographic lines, thinking that that's correlated with voting intention. So how did it play out? Who was right? Well, the fact that you've probably never heard of Alf Landon should tell you who was right. This little map kind of shows you just what kind of a landslide this was. These are the results of the presidential election, and FDR won almost every state. Like Vermont and Maine, that's it. 8 electoral votes for Alf Landon. How could the Literary Digest be so wrong? And we're talking they were really wrong. This is a finer breakdown of the results. So the Literary Digest had predicted that Landon was going to win 57% of the popular vote and have 370 electoral votes. Now, in real life, there's 2 middle columns. FDR won 62% of the popular vote. It was a landslide in the opposite direction. And he won almost every single electoral college vote, 523 to 8. Let's look back at the actual percentages. 62% of voting Americans voted for FDR. Gallup thought it would be 56, but he was a whole lot closer. If you do rounding, 62 is like roughly 60, 56 rounds up to 60. Gallup pretty much nailed it, especially in contrast to the Literary Digest. Now, what did Literary Digest do wrong? They had a huge sample size. Well, what they did wrong is they oversampled a particular type of person. In 1936, we were in the middle of the Great Depression. Plus, not everyone had telephones back then. So if you were unemployed, as a lot of people were during the Great Depression, or not very well off so that you didn't have a telephone in the first place, you weren't likely to be selected for the Literary Digest questionnaire. Now, if you were wealthy, you were part of the Rotary Club and the Kiwanis Club. If you were a working person, ain't nobody got time for that. So you were never on the Literary Digest's radar. They also used subscription lists, their own internal subscription lists for the Literary Digest. That's a rich person magazine. The Literary Digest? Working people don't have time to read the Literary Digest, much less poor people subscribing to the Literary Digest. Wasn't going to happen. So even though they had a really big sample size, they oversampled very rich, well-off people. Granted, those folks tended to vote for Alf Landon, but that wasn't the question. The question was, what was the voting population going to vote for? And they did not vote for Alf Landon. They voted for FDR. So that was a huge lesson for statisticians. Take very special care in selecting people into your sample. Don't just opt for a large sample size. Now, all else equal, bigger is better. But often all else isn't equal. You want to make sure it's a representative sample. There are all kinds of different samples. In your own life, when you're wondering, what do people think about X, Y, and Z? This particular musician or that particular movie. You take an informal poll. That's what you do when you're asking your friends. You're not asking the entire population. You go out to your friends and you say, hey, what'd you think? Was it good? Is it worth watching? Is it worth listening to? Now that's very convenient, but all it's going to tell you is what your friends think. It might be useful because ultimately you want to know, will you like the movie? And if your friends and you have similar tastes, as you often do, then hey, that might not be a horrible sample. But if the question is a little bit more broad, like, do you think a particular movie is going to win an Oscar? Then your friends are not representative of the Motion Picture Academy. Another type of non-probability sample or non-scientific sample would be a voluntary sample. Now, this is a bad term. All samples ultimately are voluntary, actually, except for the census. You're not allowed to not answer the census. But every other sample, every other questionnaire, you can say no. But really, what voluntary sample, what that phrase is intended to convey, is the idea that sometimes people seek out the sample. They self-select into that sample group. And that makes their participation a little bit suspicious. So here are 3 different examples. Political polling. Now, sometimes, not always, but sometimes political polling is actually intended to be biased. Hard to believe. But let's say that a political party, either political party, wants to drum up support for their candidate. Then they'll put out a poll and they'll mail it to their own party members. And then they'll try to spin it as though this is representative of the population. So if the Republican National Committee mails out a big questionnaire to their mailing list, which is pretty much Republicans, and they say, hey, how's President Trump doing? Then the questionnaires will come back, yeah, not bad, he's doing well. And they can say, look, the nation agrees, President Trump is doing great. On the flip side, if the Democratic Party sends out questionnaires to people who are registered Democrats, then those people have, by their own actions, made it more likely they'll be sampled by the Democratic Party. And they're going to have a completely opposite view on how President Trump is doing. So people, by joining parties, kind of self-select into party line polling. Online questionnaires are, I think, another type of example of this kind of thing. Right? So if you go on ESPN.com or CNN, Fox News will have a pop-up ad, and they'll say, what do you think about X, Y, and Z? And they'll say 80% believe yada yada. At most, what they can say is 80% of Fox viewers, because Fox viewers are very different from CNN viewers. And likewise, CNN, when they do their polling, they should have a disclaimer that says, the majority of CNN viewers believe X. And they often don't say that. They'll just say, according to a poll conducted by Fox News or CNN, 80% of people believe X, Y, and Z. See, you, by visiting the website, self-select into a sample pool of people who might receive that questionnaire. So, are you equally likely as your conservative Uncle Bob to take a Fox News poll? Don't know. Maybe not. Probably not. Is Bob as likely as you to be selected into a CNN.com poll? Probably not. So you going to those websites changes your probabilities of being selected. And that's where the problem kind of comes up. If you want to have see another great example of this kind of voluntary sample, I invite you, I beg you to read the chapter in this book called How to Lie with Statistics. The chapter is called The Sample with the Built-in Bias. It's a great chapter. Here's a brief synopsis. People go to their high school reunion and they say, hey, what's your income like? Well, income is going to be huge because, one, people are going to kind of round up because they want to impress their high school friends, their former classmates. But a lot of people who are embarrassed about their job prospects might not even go to the high school reunion. They'll never be asked the question because they've selected out of that sample. And by the same token, people who have done really well for themselves, they want to show off. They will go. They're more likely to go to the high school reunion. And so they're more likely to be asked, what was your income? So people can change the probabilities of being selected and that skews the results. All right, so what are you to do? You want to have a good sample. Is there a scientific kind of sample that you can draw? Here I show you 3 different probability samples or scientific sampling methods that tend to work. The gold standard one is the simple random sample. Now, what that means is that every single person in the population that you're trying to learn about has an equal likelihood of being selected into your sample. Now that's kind of hard to do. Really what you need is a list of everyone in the population, which you might not be able to get. But if you have that list, then you can use some random number generator to randomly select your sample for you. If you can't get that list of the population, then simple random sampling can be a little bit difficult. There are some alternatives. A systematic sample is one where you're just going to select every 10th person, every 100th person, or so forth, to participate in your sample. So if you did have a phone book, you could take every 100th person in that phone book. Now be careful, the phone book, might not be the population you're interested in. But it's systematic in the sense that you're just taking every nth person. As long as the underlying list of people who go by your checkpoint, let's say, as long as that is random, then if you take every 10th person, your sample is also random. Now, if, however, people go through your checkpoint or they're listed in a non-random fashion, then if you're taking every 10th person, you just have also non-randomness there. So you have to be a little bit careful with systematic sampling. Now finally, stratified sampling. And this is the one that's most similar to what George Gallup did back in 1936. Let's say that we want to know about the US population and how they're going to vote in the next presidential election. We know we can't sample absolutely everybody. We could take a simple random sample of all registered voters, but one tweak that you could do is, let's say that you know that 50% of the US voting population are men and 50% are women. Then if you just took a simple random sample, you might randomly get 60% women and 40% men. And you know that's not representative of the truth. So instead, split up your sampling frame into men and women, and then go out and select 50 men and 50 women. And then you've got those proportions right. You could also, how many voters are in each particular state. So when you're seeking to construct a sample, if you know that the percentage of US voters that come from Louisiana is only 10%, it's not even 5%, then go out and select yourself 5% of your sample being from Louisiana. Likewise, if you know that such and such proportion of voters are Democrats or Republicans or independents, then you can go out there and select those proportions of Democrats, Republicans, and independents. Now, if you have that information about the population, use it. Do this kind of stratified sampling. The danger in using this, though, is sometimes you don't know the proportions of the population. That's why we're sampling in the first place, because we don't know something about the population. So stratified sampling kind of presumes that you know some things about the population. You don't know the actual thing you want to know, but that you can kind of at least mimic the population using the information you do know about the population. That's actually why a decennial census, that 10-year census by the US government, is so useful, because we have then a pretty good idea of demographic breakdowns, age breakdowns, income breakdowns, party registrations, and so forth. And then we can leverage that year after year as we're constructing stratified samples to learn other things about the population. So we've established that we are pretty sure we want to have a random sample. Okay, so we've got that. Now, let's say that we want to know how large is the average family. There's still a very practical question. We know we're going to take a random sample, but a random sample of who? We could have two options, for example. We could ask a random sample of people, how large is your family? Or we could take a random sample of families and ask them, how large is your family? And let's ignore the practical complication of how do we define family? Is it the nuclear family, the extended family? Let's brush that aside for a second. In these two cases, we're still doing random sampling, but we're randomizing over two different things. In one, we're randomizing over people, and in another, we're randomizing over families. And these are two slightly different approaches. They're still random, but they're different. Which one's better? Here's a simple example of the differences between these two approaches. I've got here 4 families: the star family, the red square family, triangles, and circle family. And in the first family, they've got 5 people in the family. The other 3 families, they just have 1 person in each family. Now, how large is the average family? Well, let's do this over families, the proper way. So we've got, how large is the average family? Average family is, well, we have 5 in the first family, 1 in the second, 1 in the third, 1 in the fourth, and then we divide by the number of families. 5, 6, 7, 8 divided by 4. That gives us 2. But what if we had taken a complete sample, but we did this over people? So we're going to ask absolutely every single person, how large is their family? And then take the average of those responses. So if we're sampling over people, then our estimate of the average family is going to be very different. So we ask this first person, how large is your family? He says, oh, 5. Okay. And then we ask the second person, how large is their family? He says 5. And then this third person, how large is your family? 5, and 5, and 5. So we got 1, 2, 3, 4, 5 folks. We asked all of these folks, how large is your family? They all said 5. Then we asked this person, it was 1, and this person was 1, and this person was 1. So 1 plus 1 plus 1. And then we divide by how many people did we ask? We asked 5, 6, 7, 8 people. Well, that's 28 over 8, which is 3.5, which is a much bigger number than the true number, which is 2. You see, we oversampled people from large families. This is very similar to the Literary Digest problem of oversampling people who aren't representative of the whole. So in closing, don't just rush to, 1, believe somebody else's statistical analysis, or 2, rush to quickly calculate means and medians and averages and things like that from any old data set. Data are collected by people. They're flawed people who might be making honest mistakes, or they might actually be making purposeful ones and trying to mislead you. If you're collecting your own data, try to minimize the error and the bias in your work by collecting a random sample, a simple random sample. If you are using somebody else's data, poke underneath the hood. Try to figure out how they selected people into their sample, because it might be a very biased sample. It might just be bad analysis, or they might be trying to mislead you. And that happens a lot. Okay, that's it for now. Thanks for listening.